Before we start, let me recap week one. It was just first week of our training. So we started with very basic topics. We understood .NET platform, C# programming language, and we also understood what is NXOpen APIs. So uh, we had a very good introduction of all these basic stuffs. And then we started with journal editor journal editor and also we have seen how you generate template code, what are the components of template codes, then journal examples we have seen, then we have also seen API reference guide, how you download that, how you start using that, different namespaces, classes, members of this API guide, and then we have seen data types in C sharp and also data types in NXOpen. We have seen various examples of those, and also we tried to backtrack the examples uh, in API reference guide. We have tried to identify the APIs used in journal, and also we tried to locate the respective help page of those APIs in API reference guide. We have also tried to identify different types, data types, variable types in a journal. We have even tried that on a recorded journal, and we have seen what is the difference when you write your own code and the code in journal. Also, over the weekend, I have shared with you the videos to go through Visual Studio. I have given you the introduction to Visual Studio, and I have also given the steps for you to download and install Visual Studio. This week, we will start using Journal Editor and Visual Studio both to start writing a program. So with this recap, let's move on. We'll repeat the instructions one more time for this week. As always, attend from laptop or PC. Do not perform anything parallelly. Full focus on what I am going to tell you, what I am telling you. Try to understand, try to grasp it 100%. If you have that clarity, then you will definitely be able to perform assignments or any stuff yourself uh, after the session. Also, keep yourself muted. If you do have any questions, you can definitely ask in chat box. But I would recommend you post that question into a Discord rather than chat box because we cannot save the history in chat box, but we do have that history stored, conversation history very well stored in a Discord. So ask that in Discord. That will be much better. Yeah, no Q&A in between. We do have dedicated time and space. Uh, as usual, as we have done last week, we are going to have the Q&A session this week as well. And it's your job to ask too many questions so that I need to prepare to have this Q&A call. So you have to do a job for making that Q&A session much more effective. So do that, and as you post your queries in Discord, do the same thing for learnings. In a learning challenge, in a learning channel, go and add your learnings day by day. Each session, whatever you have learned, I assume that you are taking notes and you can post those notes into the learning channel so that uh, I know that you have learned, and also other people also know that you learned what you learned from that from the session. So follow these instructions, and with this, we are ready to move to the topics for today. We are going to touch upon NX objects in this session. So what we have seen last week, data types. I tried to cover data types into C sharp, native data types of C sharp, as well as data types of NXOpen. But in order to clear the confusion between data types, what we will do is the types in NX, we will call it NX objects or other objects. So when I will talk about types in C sharp, I will like use the name data types, and when I am talking about the types in NX, I will use objects. So it will be data types and it will be objects. So in order to not have that confusion, we will use these names. Now let's talk about NX objects. Now, how we navigate to the objects. We already seen this, but let me take you through that navigation one more time. So it is objects, and for all the objects, across all the objects, this is what is the navigation. Navigation means we start with namespace. Namespace is actually bunch, a certain type of bunch that do have several classes, and within each class we do have bunch of APIs. We can call it either APIs, we can call it methods, and some of them are properties as well, or even members. So uh, this is one and the same thing. So namespace, then classes, then members or methods. So this is the navigation steps across any object. So let's see this same thing in a API reference guide. Now I am at home, a home page of the reference guide. Now let's see if I get inside this namespace, NXOpen dot annotations. And we do have different tables here, but let me take you to the classes table. Now NXOpen dot annotations is a namespace. That namespace provides classes and interfaces related to dimensions, nodes, symbols, PMI, and other annotations. So this is the house of all those classes, all those APIs which are relevant for dimensions, nodes, symbols, PMI, and other annotations. Now classes, what classes is? It represents a specific thing. It represents angular dimension. It represents arc length dimension. It represents base angular dimension. If I talk about dimensions, we have several classes for dimensions. Base length, base arc length dimension, base chamfer dimension, base cylindrical dimension. Now I can tell you one thing. You will find very similar classes in each of the namespaces. Now, what obvious question out of curiosity you will have is that what is difference between angular dimension and arc length dimension? Maybe this difference is easy to find out. You might know it already. But if you come across a complex class, for example, this base angular dimension and base chamfer dimension, or even base cylindrical dimension, base diameter. So you might get little bit confused by reading the similar class names. So I can tell you that do not get into that much detail, because this can give you this can make you little bit confused. So don't get into that much uh, uh, curiosity. Of course, there is a way to find out the difference, what is difference between two, what these different things are to get separate. So all of that, but initially to start with, do not look into that much details. It will be better for you. Okay, so let's move on. So you can see huge list of classes when it comes to dimensions only. Okay, so each of these represents the specific type of dimension. That's for sure. Now, if I get into base hole dimension, Now I can see there are various APIs here. So those are either methods or properties. So you don't need to look into that much details what is methods and what is properties, not required. So this is nothing but you get into this all members and you can see all the APIs of this class. Now if I do it for anything else, even it remains the same. Navigation remains the same. You start with namespace, then class, and then API. Now, how this navigation structure is going to help you. Now you are not that much comfortable about API guide, but you do have a very good knowledge and understanding of NXCAD software. So you wanted to find out some API yourself. Now, for example, let's talk about a specific feature, uh, chamfer feature. Okay. Now you wanted to find out some API related to chamfer. Now your search starts with namespace. So you will first go to namespaces, and by common sense or by your understanding of NXCAD software, you will try to identify which namespace you shall look into. Now, as chamfer is a feature, then you can look for feature namespace. So we do have NXOpen.features namespace. You will get into this. Now, in the classes, you will try to find out the chamfer class. What you can do is simply Control F and then chamfer. I don't find it. Okay, spelling mistake. Chamfer. Okay, so I get the chamfer class. It represents chamfer feature. Then you click here. You landed into the APIs page of the chamfer. So this is the chamfer class, and we do have several APIs here with the details. So this is how you land. So first, if you're able to find out which category, which namespace it is, then your search is easy. So this navigation helps you that way. And the best part is across all objects, this navigation is same. This navigation does not changes with the object. Now let's come back and let me show you what I mean by objects. So whatever you have listed down as a data type in the one of the assignment done last week, where we have listed down all the data types in a recorded journal. So if you remember, that entire journal do have only types from NX point of view. So I'm calling those all types as a object. Now I can tell you more about objects. So this is one inheritance hierarchy point. Under this heading, we can find various objects. So chamfer is one of the object, and this is the hierarchy to uh, to find out the object or to locate the chamfer. Now, if I click on body feature and if I scroll down, you can see we do have this list of the objects. So many of them are either from CAE or some other advanced area of NX that we don't often use. So I will try to find out which is very familiar to us. For example, chamfer, then cone, then cylinder, then delete body curve edge, and so on. Draft body, edge blend, emboss, extrude. So these are all body features. So body feature is not just a category, but it also itself a object as well. And these are as well whatever name I have just read out. All those are also objects. So any object you pick up, what happens if I click on cylinder? You will go to the cylinder class. If I again go to body feature and click on slope, then we get into the slope class. So this is another navigation, and that navigation happening through the inheritance hierarchy. Now uh, I told you about object. So if I click on object, which is the top level thing, actually that might not open anything uh, in uh, in the reference guide, because object is something which is a very generic term. Is whatever that we access, whatever that we work inside NX, that can be object. So that's why it is very vague term. So that's why I don't get anything else. So what makes sense is browse objects from this level, tagged object level, or even some objects are there in NX remotable object, but it makes sense for uh, easy dive into this topic. We start from NX, not NX tagged object. I will tell you what is tagged object later. It's not time to do that now. But these all are, you can see, all those are objects. And if I click on any of these objects, then most of the times I land in the that's uh, object specific class. Okay, so this is how that navigation remains uh, remains relevant for any any object. Namespace, class, methods, properties, members. Now, as I told you just now about hierarchy, it also, the other way of navigation is through hierarchy. So objects are, everything in NX is object, in short. Everything in NX. If I tell you about the sketch, for example, so sketch feature is an object. Then plane on which we create sketch is an object. Then direction that we use as an input for creating sketch is an object, or for creating plane even. Then origin that we use for creating that sketch, that plane is also object. Whatever curves, line, arc, ellipse, circle, parabola, hyperbola, whatever center line, points, all that are also object. Constraint, we add tangent constraint, we add coincident constraint, concentric constraint. All those are also object. We add dimension, that is also an object. So everything that we work inside NX is object. Uh, now, now we are talking about navigation. So one way is namespace, classes, and then the API. The similarly, we can also navigate to the relevant API or relevant stuff through the hierarchy. So object is being the top level thing, top level object, which is very generic level. Anything that we are dealing with in NX, we can classify that as an object, or even we can uh, define that as an object, because it is generic level and it is very broadly used. We don't recommend you use anything as an object type, the type of that variable as an object, because which is very broad level, and that is not going to help us at all. Now we do have another broad category of objects, which is called tagged object. I will come to that later, but to tell you about the tagged object in one line. All objects that do have a tag are called tagged objects. Now we do have an X object as well, which is widely used generic type object, which is also generic in nature, like object, but it is used widely, and this is not at all actually used. In a very special case, it might be used, but I don't find that case even now. NX object is broadly used, but this is also the one way to navigate and find out the relevant class and relevant API in NX. Now let's talk about few examples. We start from object, the top one, okay, and then as I told you, it is better makes sense to navigate from the tagged object. If at all you are using that inheritance hierarchy uh, uh, point to navigate to the specific object, you can start from tagged object. But to start with, navigating from the namespaces is easy because you can use a common sense of your understanding of NX, and that you can use to find out the relevant namespace, and then finding out the relevant class is easy through that way. But this is another way, and which is also very useful, uh, and that's why I'm sharing this. So tagged object, then NX object, which is widely used generic type object, and then if any object that you are dealing with, if it is displayable object, displayable means all those objects that can be visible in a graphics area in NX. So you know what is graphics area. So in that graphics area, we see the geometry. So any geometry related object which are visible in the graphics area are called displayable object. And there are few objects in this category which are classified as smart object. Those smart objects are axis, curve, plane, point, direction. And then within this smart object, if I drill down further, we can have curves, and within curves, we can have lines or arcs. So this is one example of hierarchy. So now we are talking about the hierarchy examples. Now let's see this in the reference guide. I will start from here, namespaces. We'll get into, not namespaces actually, it won't help. It is okay if I am into this selection, select dimension. Okay, what I will go to, I will go to inside tagged object. Now inside tagged object, I will find out NX object. I will follow the hierarchy that I have shown in the slides. We'll find out NX object. It will be much more difficult if I like do it like this. NX object. Okay, so I found this NX object. If I click here, NX object, then I can see NX object class. Now I want to find out displayable object. I want to navigate to the curve or arc. So now I will displayable object. Yeah, so this is a displayable object. Now I can see the displayable object class, but I will go down into the hierarchy again. Now, if I don't know what is displayable object and I want to know what are those different objects, then I can just read these lines, read these object names, annotation, component, body, then datum axis, datum plane, and face edge, faceted body, faceted edge, component. So all of these are displayable objects because these all we can see in a graphics area. Now I am talking about smart object. So let's find smart object. Here it is, smart object. And then within smart object, what we have? We do have axis, curve, direction, offset, plane, point, etc. Okay, now I want to navigate to the curve. And within curve, what we have? We have three types of curves: conic, line, and spline. Now let's see what is conic. Conic are arc, ellipse, hyperbola, and parabola. Then line means infinite line and line segment. And then spline is something else, which is spline segment. Okay. So what I understand from this is that from this navigation is, though line, spline, arc, circle, all those are fall under curve class or curve object, but still point is different than this. So it means that inside the smart object, we do have point as different object. It is not under curves. So this is what I can understand now. Uh, this hierarchy is not just useful for navigating the API guide, but this hierarchy is also useful for using that specific API. It means that point is different class, curve is different class. It means that if I wanted to create the point, I must use the API from point class. If I want to create a line or arc, I must use the API from curve class. So it is that much clear by this hierarchy. Now let's take another example of hierarchy. Object, tagged object, NX object, and feature. Feature does not fall into displayable object because we cannot see a feature in a graphics area. We can see the object, either body or face or edge, which is created from that feature into the graphics area, but we cannot see the feature. Feature is extrude or hole or revolve. So all those are features, and those features are we can found it in part navigator, not in the graphics area. So that's why it is not a displayable object. Now let's see this hierarchy of feature. NX object, and then we need to find feature. Feature. Now if I get into this feature class, I can even find the list of features which we already have seen just now. So we do have body feature, we do have datum coordinate system, datum feature, etc. So this is huge list of features. There is slight difference between body feature and feature. Body feature is actually the feature on a part that has a body associated with it. Means there are some features that not actually create a body, or the body is not associated with that feature. But this body feature class is specially meant for the features which are having body associated with it. So this is a body feature. So this is how we can navigate here. And now if I want to create any feature which we can see into part navigator, uh, for that purpose we have to refer to the feature class, and for the specific feature we have to refer to that specific feature class. So we cannot go to displayable object category for working with features. We have to get into this, and the same applies for annotations. Uh, Now let's see the another example. I have gone to home, then annotations, then angular dimension. Now I will scroll down to the hierarchy. Now you can see displayable object, annotation, dimension, and then base angular dimension, and then we do have angular dimension. This is the hierarchy for this angular dimension object. So if so, in order to navigate to the specific page, this hierarchy is useful. So we don't need to really remember this hierarchy, but this hierarchy is very well useful to understand from where you can access the particular API. For example, now let's talk about inheritance. So this is about hierarchy. Don't need to get into that much details again. Again, I am emphasizing because this can confuse you. So just uh, be comfortable uh, knowing that there is a API reference guide for you to rescue you at any point of time. The only thing is that as much as you go through it, as much as you look at this guide, you will become comfortable with it. You don't need to even remember this hierarchy, right? Because this hierarchy you get ready-made here. The only thing is that how you use that API, that also matters, or that also is indicated from this API guide. Now we have seen hierarchy. We have seen hierarchy for the curves or lines or arcs. We have seen hierarchy for feature. We have seen hierarchy for dimension. Now let's see its relevance when it comes to the inheritance. Inheritance means there are some APIs which are common across most of the classes. So if I tell you, let's take the example of annotation class, and dimension class. Okay, so there are some APIs which are common to annotation as well as which are also available to use from dimension class. So this is the list of those APIs: annotation origin, annotation plane, then get associative origin, get associativity. So these APIs, you can see these are inherited from annotation. Inherited from annotation. It means that these are also available in annotation class. And as those are also available in annotation class, if I go to annotation class, it means that those APIs I can use for any of these objects. It can be dimension, it can be just an arrow, it can be hatch, it can be title block. So all these different objects, I can use those APIs because it is inherited from annotation. Now, if I want to see the APIs which are only relevant for dimension class, then what I need to do? I need to untick this checkbox, inherited. So it indicates that all of the top level classes, then dimension, all of the top level objects, uh, hierarchy wise. So if there are any relevant API which is applicable here, those are also listed. But if I untick this option, inherited, it means I will only see the APIs which are exactly relevant for dimension. We won't see any API related to displayable object. We won't see any API related to NX object. We won't see any API related to annotation object. We only see the APIs related to dimension. So all these APIs which are listed here, all are only relevant to the dimension class. So if we wanted to be specific, then that time we can use untick this inherited option. And this is the significance of inheritance, because there is many common things between the different objects, and to have that common linking between those, this inheritance hierarchy is created. Okay, I think it is too much about the theory part. Now let's see what do I have on the slides. uh, Collection part we are not going to see it right now. I will cover it one of the examples, so I'm parking that for now. Inheritance is actually to make our life easy, because if there is no inheritance, then it will be too much tedious for us to use any API. For example, uh, if you remember, we do have used get length API in one of the example to get the uh, length of line or arc. Okay, I can go to that example because you will be able to understand much better. Oh, it's too much to navigate for me now. Okay, create no, get length. Yeah, so this one. Okay, you can see this get length API. This API is can be found under curves. CUR is nothing but the curve. Okay, so if I go to get length, or if I go to the curve class, let me find it here, curve class. Okay, and in curve class we do have get length. Get length. Okay, so it returns the length of the object. It means that in curve we do have several objects. We have conic type of objects, means arc or ellipse. We do have line, and we do have also spline. So all these are sketch entities, and because of its inheritance nature of this structure of APIs, it is easy. It made our job easy because I do not need to refer to the other API for getting the length of other object. Means whether it is arc, whether it is line, I don't need to bother about, because whether it is line or arc, I can use get length to get to the length of that entity. So this way, it has made our job easy in a way, but provided we understand this inheritance structure. Similarly, you will find many common APIs. For example, get name, uh, name or get name. So this name means any object is there, whether it is sketch, whether it is feature, whether it is datum plane, anything. So in order to get the name of that object, this API is used. So it returns the custom name of the object. Object can be anything which is under NX object. So it can be any object. You see, this is huge list. Even displayable object is here, feature is here. So huge list of objects are here, but all of those objects name we can find out with name API. So this way it makes our job easier. Okay, so this is about the objects navigation, its inheritance, and its hierarchy. Now let's talk about some NX object examples. I do have planned to give you the practical, uh, what we can say, a practical aspect of what we have learned now. So what is that hierarchy inheritance helps you? So we'll understand that through a very simple example. We'll first create a point, and then we'll create a ellipse, and then by the difference of these two, we'll understand the implication of hierarchy and inheritance. So let's get into the NX. What I will do is I will get into the template code. I don't need this line, so I will remove this line. And now I'll copy this line, part.work part. That is again a standard code of line that we know. Now, what I wanted to do, I wanted to create a point. So in order to create a point, I must first define a point 3D. So how we define point 3D is point 3D, sorry, like this, point 3D. We first define a type, then identifier as P1. By this time, you must have uh, very well understood this syntax for uh, variable definition. Okay, so data type, object type in this case, then identifier as P1, then is equals to its value. So as we know that we need a memory allocation for point 3D, so we'll use new space, then point 3D. I must use P as capital because C sharp is a case sensitive language. Okay, and then into bracket 10, 10 and 0, bracket complete, semicolon. So I have uh, defined the P1 variable. Now I wanted to create a point. Now you will say you have created the point in the journal itself. Now why you are going to create a point, new point again? Actually, I can tell you this difference. Now here again, this API reference guide will come for you this rescue. Now we know that we have created such such points already to create a line. So these points are used to create a line. Now I want to use this same point to create a point actually, but there is a difference between point and point 3D. So I can tell you that difference through the API guide. Now let's see point. So we do have point class and point 3D. So there is no point 3D class, but point 3D do have a structure and there is a constructor as well. Constructor means we know that what we need to specify to define a point 3D. We need XYZ and the type for the XYZ values is double. So we know this. But then what is the difference between point and point 3D? So okay, let's get into this class. Let me see if I find out something in this class. Yes, so we are into this class, but I think I am not able to find what I am looking for. I am looking for an API to create a point. Okay, I don't find it here. Now what I will do is I will try to use the search method that I have. Okay, so I found create point method, and what I need is create. You can see how there are huge list of methods available. So there are lot of alternatives we do have to create the point. Now I don't want to get confused. So what I will do is I will use the first method as is. Okay, create point. And you can see the first API create point. What it says, it creates a point without parameters. But what we need is point 3D as an input. So let's understand now what is difference between point and point 3D. So we already know point is actually the three-dimensional Cartesian coordinate that represents a point. It only represents the point, but it is not actually the object. It is not actually the point object. It only represents the point using those three coordinates, but it is not actually the point that resides in NX part. Whereas point is, it represents the smart point. Smart is the category of class. Ignore that for now. It represents a point, and this point is actually the point that resides in NX. So how we create that point is using the inputs from point 3. So let's try to use this create point API now. I do have an input required for that API or for that point or what I am going to create now. So I know that now. Similarly, how I defined the point 3D, I also need to define point. So what I will do is point, and the name I will give you as real point. That's it. Okay, uh, I do not give the value for now. So this way I have defined the point. The first point I will repeat. First point, which is point 3D, is a virtual point that only represents the coordinates for the point. But this point does not actually uh, can be seen in NX. But this point is actually the real object that we can see in NX. Now I do have these two objects created. Now I am good to go and use the create point API. Now how I use that API? So I have to start from work part. Work part dot points dot create point is the API name that I have found, and then into bracket I need the input as point 3D. So that point 3D input name is P1 because that is the identifier, that is the name of this point 3D variable. So create point and into bracket as P1, which is point 3D. So this is I have given. Now let's go to the API reference type again. So for create point into bracket point 3D, which is P1 we have mentioned. Now before this create point API, I have used work part dot points. Now you will say what is that? So you can see the reason for that here. Point collection, NXOpen point collection, and then create point. So work part is the active part where our program is going to perform something, perform some automation. So that's why that work part is required. And we can create the point from the point collection class. So you can remember, miss, not remember, but what we have seen just few minutes back. I tried to find out the create point into point class. If you remember, I have find out this point class, and I tried to find the create point API here, which I not managed to find. That is because the create point API is not in the point class. It is inside point collection class. So if I navigated to point collection class, I would have find create point API here. So as it is under points class, I have to use points in my code. Point collection is nothing but plural form of point. So point means singular and point collection means multiple points, more than one. It is plural. So that's why work part dot points dot create point. That's why this is the way I have to use or I have to access this API. If there is any collection mentioned, it means it is plural. It means it is more than one. And that times, if it is curves, we use curves S. If it is point, we use points. Adding S to that. So this is how we go and navigate to create point. Now this is created, and now I will go and use this point, and then is equal to, I will mention this line which will create a point, and then that point object will be assigned as value to this variable. This is actually a path from the API reference guide. Work part dot points dot create point, but it is hard to find the exact path. But navigation wise, we can correlate, because anyway, to create the object, we have to start from work part. That is very obvious thing, and by uh, when we go through several examples, you will understand that very well. We have to start from points to create point, and that kind of understanding that we get from this class. Point collection class, we do have create point. It means we this path to follow to create this path to follow to use create point API. We can understand that it starts from here. So it is point collection class. It means that points dot create point. Okay, and then there is one more thing about the smart objects. There is one line of code that always needs to be there. uh, I will copy that line and we'll use that into our journal. Smart objects are by default invisible. Smart objects are by default invisible in a graphics area, and we have to set them visible. And to set the visibility, this is something that we have to use. Real point is the name of the point. Dot set visibility. So this you can understand. This is a constructor. So this constructor requires this option stated into the bracket, smart object dot visibility option dot visible. So this makes this visible. What is smart object? I will come to that later, or rather, it is not required to focus at the moment. Okay, now this is all done, code point of view. Now let's uh, run this journal and see if this creates a point. Sorry, I haven't had any active part. So maybe it is not going to work. I need to open at least a new part, and then my journal will work. Okay, so now I will run this again. You can see this is a point. This point is added. Now let's okay. So this is about the creating point. There are some trial errors we can do with this code, but I don't want to divert from the topic for now because I want to explain you this example with context to the hierarchy of the objects. Okay, so we have started from points dot create point. Now, one thing I can definitely tell about smart objects, if I go to NXOpen, okay, and go to point and go to the bottom of this page, here we see smart object. And if you wanted to know what is smart object, then if I land in the smart object class, then you can see all of these type of objects are classified as smart object. Axis, mesh point, coordinate system, curve, direction, offset, uh, plane, point, anchor, control point, port, scalar, XForm. All these are classified as smart object. I know that as a design engineer using NXCAD, you are not familiar with all of these. Maybe you have not seen XForm, maybe you have not seen anchor, control point, but there are lot of different kinds of objects in the when we use API. So that is the this is how it works. So can't do that, can't do anything with that. Okay, so these are the smart objects, and the smart objects do not have the visibility initially, so we have to set that visibility. That's why we have used that line. Now, with the other example, we'll understand uh, uh, more about the hierarchy. Let's try to understand, and I will be taking that quickly because I don't want to overload you with lot of information in just one session. So let me find out that. So we'll try to create the curve now. Curve. Let's create ellipse. And how we create ellipse is again the API reference guide from where we will start. I want to create ellipse, so I will type ellipse, and now we are into ellipse class, and this ellipse is actually part of conic curve. So you can see here we do have this remark. To create the new instance of this class, use curve collection dot create ellipse. So I can start from here. I wanted to create a ellipse and I do have got this from remarks itself. I can get into curve collection dot create ellipse. Now I will not go into that much of details of create ellipse API. I can go into curve collection at least. So you can now correlate this with point collection class. So in point collection class, we do have the API to create point. Similarly, in curves collection class, we do have the API to create arc or even to create line. So, okay, ellipse example we can take little later. First of all, we can go and see the create point example. Sorry, create line example that we have already uh, seen in the last week itself. So if I go to this one, create line, you can see how we have started work part dot curves dot create line. So where from this curves is coming, because create line or even create arc is available within curves collection class. This is why we do have to start from curves. We obviously start from work part, so that is fine. So it is curves dot create line I have to use. If I don't use it, let's say if I delete this and directly use create line, this is not going to work. Instead of curves, if I use something else, for example, I am creating lines, right? So obviously, by just using common sense, without using API reference guide, I can type it like this: lines dot create line. Let's see if this works. It is not going to work. It says that NXOpen dot line connection does not contain create line. Okay, it means that this is something that I cannot use. So I have to only use curves, because this is how it is hierarchically structured. The same goes for creating arc. Even creating arc, we have to start from curves. You can see the constructor is different. The parameters that we have used is different, but this is how we have to start. And this is the importance of going through the hierarchy. Now, if I get into the API reference guide again, you can see we do have various methods. We can create arc with these any of these three methods: create arc, create arc, create arc. We do have create ellipse one, two methods. We do have create hyperbola, two methods. Create extracted curve, we do have this method as well. Create infinite line, we do have two methods for creating line. uh, Create parabola, we do have a couple of them. So all of these APIs can be only used when we access this curve collection class. It means curves dot the API we wanted to use. So this is how we initiate the use of that API, provided we also use the constructor. Very right, constructor meaning all the parameters in the bracket are used, are declared as a variable and are used exactly the same way those are stated in this API. And this is how we can create that uh, that object, whether it is arc, parabola, line, whether it is point. Okay, so this is all. Let's see. Okay, don't wanted to confuse you. Let's see one more thing. Extrude collection. Do we have extrude collection? No, we don't have extrude collection. Let me show you one more example. If I found something very similar without confusing you. Axis collection, yes. So we do have axis collection, and uh, there are methods: create point, create axis. So there are three methods to create the axis, but it is from axis collection. So we have to start from access dot create axis. So this is how it can create the axis for us. So most of the times, this is how the structure is to create the objects. There is much complex ways as well, but that we will see later. So this is about uh, the navigation, the hierarchy, and the importance of that hierarchy in using the API. Okay, so that's all for today, and I will give you definitely the assignment to work on. I know that this can be much of a complex topic, and that's why it has taken that much time as well. We exceeded the time already. It is almost 10-12 minutes more than uh, the hour that we continued. But uh, understanding that hierarchy is going to be much more useful for you going forward. You don't need to more about bother more about that, because there is a API reference guide to your rescue at all the all the times. It is just matter of your understanding from the API reference guide. Okay, so that's it. What we'll do tomorrow, we'll continue going through the examples. Those are based on this topic of hierarchy that we have seen today. So it will help you, that those examples will help you understand more about the same.